Hi guys, in this video series I'll show you how to build an NFT Marketplace application. This application will be built with Next.js, Polygon, Hardhat and TailwindCSS. So this is the application you're seeing right now, and this is part 2 of this video series. So before I get into that, so this application basically allows us to sell NFTs, buy NFTs, and list NFTs currently for sale in its marketplace. It connects to the Polygon network and uses Matic as its currency. In this video, which is part 2, I'll show you how to set up Hardhat, the Solidity smart contracts, and some scripting files to aid in the deployment process. So in order to follow along with this tutorial, go to my GitHub repo, which is in this link. I'll paste this link in my video description so you can easily obtain it. Just go to the basic structure branch, click on code, and then download zip. This will download a zip file into your downloads folder. Extract that and import it into your coding workspace so you can follow along. And it'll make it very convenient for you to follow along when you do it this way, or you could build it on your own as well. So now that we covered that, let's go to our application here. So what we're seeing here is the package.json file. So in here we have all the dependencies. So make sure to install all the dependencies listed in the package.json file. If there are any errors thrown, identify the specific package that's causing that error and try using a different version. Reading through the error stack trace is helpful for this. And to access the package.json file, just visit my GitHub source code repo, which will be included in the video description. So just go npm install and it'll install all these packages. And once that's done, we can head on over to the hardhat.config file. So in hardhat.config, this is where we show our Hardhat configuration, and as you see, it's currently empty, so let's add some stuff here. So first we're going to start out with the default network in Hardhat. Then we're going to define a list of networks. And Hardhat, this is the default network, and this is Hardhat's own built-in network called Hardhat. We're using this network. An instance of the Hardhat network will be created automatically when you test your contracts or run a script or task. So this will not be the network we're using. Instead, we're going to be using the Mumbai testnet for this tutorial. And what we're going to do is connect to the Mumbai testnet RPC URL. Let me finish typing this and I will explain. So this is the private key that we're going to be supplying, and since this is sensitive information, it'll be passed as an environment variable. So this is the testnet that we'll be using to deploy our smart contracts and NFTs to. The RPC in the URL stands for Remote Procedure Call, and it's a type of request response protocol similar to HTTP. And that is used to communicate with the Mumbai testnet. And our private key will be required. So we're using an environment variable to pass in our private key because it's very insecure to pass it in directly hard-coded, because then anyone can have access to your MetaMask wallet or whatever wallet you're using. So I highly recommend setting up your private key as an environment variable. And now we're going to define Solidity, the version, Okay. So we're defining our Solidity version here. Nothing too fancy. Next, we can move on to our contract file. And it's just one contract called market.sol. As you see, I have it pre-built with the shell function, so they don't have any logic in them. We'll code along and I'll explain as we go so that you can have a better understanding. So first we're extending or we're inheriting from ERC 721 URI storage. And this market smart contract inherits from URI 721 URI storage, which is basically a ERC 721 contract with the added benefit of storing NFT artifacts in a storage space that is off-chain. So off-chain means that the NFT artifacts are not stored in the blockchain. Instead, they're stored in IPFS. And ERC 721, in case you are wondering what that is an open standard that describes how to build NFTs on the EVM, also standing for the Ethereum virtual machine. So this is basically an ERC 721 token with the added benefit of storage. Now we're saying using counters for counters.counter. And this is basically a struct data type inside the counters library. So that statement means we assign all functions inside the counters library, such as current and increment, to the counter struct. Then we create object token IDs and items sold of this counters data type. And then we're creating a payable address. And payable addresses are basically addresses that can receive Ether. And so that's why it's called payable. You can pay it. And this is our listing price. Our listing price will be the price required to make a listing on our NFT Marketplace. And here we have our constructor, which is using the ERC 721 class, or contract rather, and we're instantiating the owner field. Then we can move on to market item, and in market item we're going to be defining how a market item should look like. So a market item is an item that will be posted onto the marketplace, and it's basically going to have a token ID. So this is the most important field because this is the identifier, which will be unique. And we're going to have a payable address of the seller and the owner, and then we're going to have the price of this market item, and we have a Boolean value indicating whether or not it's sold. So if it was sold, it would be true. If it was not sold, it would be false. Next, we can go on to mapping. Our mapping is already created. And missing semicolon. And then, oops. And then we can move on to event market item created. So this is an event. So hold on, let me type this out first. Index token ID address seller. So it looks very similar to the struct that we defined above. Price, and then bool sold. And now we have our event here. So This is an event, and it's basically events can be emitted into transactions log, into a transactions log that are stored on the blockchain node. So you might be asking, what are events useful for? So events are used to inform external users that something has happened on the blockchain. So think about like a subscriber publisher dynamic where you can subscribe to a certain channel, and then once that channel posts a video, let's say on YouTube, the subscriber will be notified of that event through this event feature. Note that smart contracts cannot listen to any events, so events are a kind of shortcut to access specific transactions in a blockchain. Next, we can move on to get listing price. So basically pretty self-evident in that it just returns the listing price. Next, we can move to create token. So let me code this out first. Token IDs, increment. So we're incrementing the token ID. And this is basically what we're using to receive a unique token ID every single time that we need one. Token ID. So then we say mint. So we're minting a new token. New token ID. And then we're going to call create market item. And I will explain in a second. It's just really hard to talk and type. Okay, so create token method. So this method is used to create a unique token ID that will come to represent the NFT that will be minted by the create market item method. This is done by grabbing a new token ID from the token ID object. Next, let's see here. We can move on to create market item. So again, I'll type it first and then explain. So price must be greater than 0 because an item with a price of less than 0 is not valid. That doesn't make sense. So we're just doing some sanity checks here. Listing price. And we're saying over here that the price for this item must be equal to the listing price. You can change this to greater than listing price also. So you can make it so that the price has to be something that is a bit more than the listing price, as let's say setting a minimum price. Then we define market item token ID, and then we define a new or instantiate a new market item using that struct we defined earlier, and we're going to say payable MSG sender. So this is the seller address and this is the owner's address. So the owner is going to be the current user, and false is for sold, and this is price. False because it's not sold yet, because the user just posted it onto the marketplace. They didn't actually buy it. Then we're going to say transfer tokens from MSG sender to address.this token ID, and then we're going to give it an event of the type we just created. Event market item created, and then MSG sender address dot this price and then false. And we can delete this semicolon here, and we're good here. So why is this complaining? Okay, so we need payable. And then comma here. And okay, so create market item. This method is used to create a market item. First, the item is assigned a new market ID. And then the item's details are used to create a market item class, which will be, or market item struct, which will be stored in the ID to market item array, as you see here. After that, the transfer from or transfer method transfers tokens from the sender's address to the address to the market contract instance's address. So sender's address, this is going to be the user, the current user's address to the contract address of this contract. Finally, the event that a new market item has been created is emitted in order to notify any subscribers. Next, we can move on to create market sale. Give me a second to type this out. So market item token ID price. So we're setting the price here. Market item token ID seller require. And then we're doing a check here. So we're saying please submit the asking price in order to complete the transaction. So we're basically saying that this person is trying to buy this token or NFT, and if the value that they're providing, if the cost that they're willing to provide to buy this is not up to the price, then we're going to say no, you cannot buy it. It has to equal the price that is listed for the market item. Then we're going to say token ID level MSG sender. And so at this point, we're basically doing a transfer. We're transferring this market item from the marketplace to the address of the current user. So we're saying sold is true, and we're saying that payable address of the current user and item sold. So now we're going to increment the number of items that are sold. So an item was just sold, so now we can increment that. Next, we're going to transfer. So transfer this item from transfer tokens from the address of the current user to MSG sender, which is the contract instance's address, and then we're saying transfer listing price, because that's the price that all items will be sold for. Transfer MSG value. So here, put a semicolon, and that should. So it's payable owner. Okay, type there. Okay, so now create market sale. So this item method is used to transfer ownership of a market item. First, we validate that the price submitted is equal to the asking price, right there. Then we transfer the market item to the buyer's address, along with transferring tokens to the owner's address and marking the market item as sold. Next, we move on to fetch market items. And this, hold on a second. Okay, so fetch market items is used to return all unsold items, as the comment says. So we're going to do count current to get all the number of items that are currently deployed to this smart contract. Then we're going to take the number of items currently held, and then we're going to say items sold. So we're going to minus that by the sold items, so we just want the unsold items. So if we minus the sold items from the total items, we are left with the unsold items. Then now once we have the unsold count, we can loop over it. But before doing that, we need to create a new market item array with the size of unsold item count in order to store all those unsold items in memory. So now we say now we're going to loop over these unsold item count plus if. So now we have to do some identifying. So we have to say item I+1 owner equals address.this. So if the item's owner is the current user, then they're allowed to fetch this item. You could change that so that all users can have access to these NFTs regardless of the owner field. But for now, this is how I'm doing it, but feel free to change it if you want. And now we're storing this item in the items array, and then incrementing the current index +1. So now we can return items, and then we have items right here. Okay, so this method is used to fetch all market items in the market smart contract. Notice that we're filtering for only unsold items and then adding them to the items array, then returning the items array, as you see here. Next, we can move on to fetch my NFTs. So as the name suggests, it basically fetches the NFTs that the user has purchased. So if you bought an NFT, it'll fetch every single NFT that has been bought by you. And how that will be possible, it will be shown. So bear with me here. Current index. So we're going to make the for loop. Total item count. If let's choose summary. Count. So we're basically getting the total count of items that belong to this user. So if the owner field equals the MSG sender, which is the current user's address, if that is a match, then just increment item count by 1, meaning that that market item belongs to this user. Typo here. So now that we have the total amount of items that belongs to this user, we can do a items array similar to the method defined above. Say item count for its size. Then we can say total items count. Now we're going to loop over this. Now we're going to loop over all the items, and we're going to say to market ID I plus 1 owner equals msg.sender. If the owner is the current user, then we're going to return that. Then we're going to add that into our array. So now we use a market item to map the current ID, so the current item. Then we're going to say current index, current item, and then we're going to increment current index by 1, so that it's incremented. So we're all adding these items. If the owner field equals the sender's address or the currently logged in user's address, then we're adding it to the items array and then returning it. Return items. So yeah, so this method is used to fetch all market items currently under the ownership of the current user. Notice that the statement used to filter all the sold items of the current user is the comparison of market item owner field to the address where the contract is being called from, which is MSG sender. So now we're going to move on to the fetch items created method, and this method basically fetches all the items that were created by this currently logged in or current user. It's not correct to say logged in because there is no login component. It's basically the way the user is identified is by the private key that was assigned, that will be assigned with the environment variable. In the Hardhat config file, it reads the private key, Polygon account private key. And we covered setting up that account with MetaMask and getting some tokens onto the account in the last video in part 1. So if you missed that, make sure to check it out, and this will make more sense there. Okay. Now we're just going over seller, MSG sender. So if the seller is this current user, then we're going to say item count plus plus, increment the item count, then same thing. So memory items, new market item, item count for total item count, and if item to market item seller equals MSG sender, then we say current ID current ID, then items, current index, item, okay, and then we can return items. So yeah, so this method is used to fetch all items sold by the current user. This will be identified by comparing the seller attribute of all the market items to the address where the contract is being called from. In other words, the user's address. So that's it for our smart contract. I know that was a lot, but try to maybe go over these methods, so if you have any doubt, they'll be clarified. So now that we've defined our contract, we have to deploy it to our blockchain node. Our blockchain node is in the Mumbai testnet. So we're basically deploying this contract to the Mumbai testnet. And in order to do that, we first have to make a script that will deploy this contract for us. So let's go to scripts, deploy.js file in the scripts folder. And I've already created a file for you, and we're basically going to code out the main method of this file. And this will do the important task of deploying the contract to the network. Because if the contract is not able to be deployed to the network, then we're basically not able to even create the application, because the network doesn't know about the contract. And the contract defines all the business logic, so basically the functions and methods that we just went through. NFT market. So basically, in the lines above, we're deploying the NFT market contract, NFT market address, and then config, and then we're going to create a file. So we're going to create an NFT market address, and we're going to assign it to config. So write file sync JSON parse data. Okay, so this part should make sense. So basically, we're basically creating a contract factory with the NFT market contract. Then we deploy it with this method, deploy. After waiting for the deployment to complete, which is indicated by this statement, we write the smart contract address to an external JavaScript file called nftconfig.js. So this is done so that the front-end application can grab that contract address to call on that contract's methods. And this will be covered in next video. So next video will cover the front-end application development. But basically, yeah, so for the front-end application to access the contract's methods laid out right here, it needs its address. But how can it get its address? It's by having an external file that holds its address, as indicated by this file. So this is the output file that will be created once I run a npx hardhat command, and that will be covered very soon. So this is the file, and it's going to read that address, and then it's going to be able to access the contract methods. So now To finish deploying the Solidity contracts via Hardhat, we're going to say npx hardhat run scripts deploy.js network Mumbai. So hopefully this works. If not, okay, hold on. We'll have to. Okay, so now we can see Solidity compilation finished successfully. Give it a second as it writes to the file. Okay, so it is successful. So basically, we're seeing that we compiled 14 files. Compilation of the Solidity contract was successful. Then we deployed the contract address, or we wrote the contract address to this NFT contract file. Now you might be wondering, where are the compiled contract files? So that's going to be in artifacts. So once I ran this command, it's automatically going to create an artifacts folder, and this is going to contain a market.sol in the contracts folder, and this is the JSON file that our front-end application can use to access the methods that are defined in our contract.sol file, in our Solidity file. So this is how the front end communicates with Solidity. It's through this JSON file. And so Hardhat makes that all possible. So that's basically it for the setup. Now that we've finished setting up Hardhat and deploying our Solidity contracts, we can move on to the next video, where we'll be covering creating and developing the front-end application built with Next.js. So see you guys in the next video.